Hey everyone, this is Mr. H. We're going to continue with the 5.2 notes. I'm on page 3 now. There's a little handy table here for function values of quadrantal angles. Those are the ones that end up on the axes. So the axes will be like a 90, or 0 or 90 or 180, 270, 360. Okay, so kind of similar to that last problem we did. That one was a quadrantal example because it ended up at 270. This one's a little different now though, because instead of being given the point, now you're given the actual angle, but we can use this table to help out. So for example, let's try number 5, find the sine of 270. Okay, so you can just look it up in the table, right? It's sine of 270 is right there. It's equal to -1, so that's the answer. So not too difficult. If you're visualizing that, you're right at 270 degrees, and think about that point, which is 0, -1. Right? Or just use the table. How about cosine 90? So we just look these up. That's right there. That's 0. Secant of 180. 180. Secant. There it is. -1. Okay. How about -90? Oof. So now it's not on my little table, but I can think about where -90 is located. -90. Remember, negative angle goes clockwise, starting on the positive x-axis. So that would be 90 degrees right there. So -90 is the same location as 270. So a cosecant of -90 is the same as the cosecant of 270. And then I can use the table. Cosecant 270, there it is, equals -1. All right, so similar, how about 540? 540 is a pretty large. Maybe I can do some coterminal work here, subtract off a 360 on that one. So that's equal to 180. So tangent of 540 is the same as tangent 180. And so if I go 180 tangent, there it is, it's 0. Okay. And then finally, -720. 720 is a multiple of 360, right? So 720 is like 2 360s. That would still be at 360 degrees, right? It would be, the angle would be this, right? You go clockwise once, clockwise again. So it's on that positive x-axis, which is 0 or 360, whatever you want to call it, right? And it's that angle there. Okay, so let's just look at it as a 360 cotangent right there. There's one that would be undefined. Okay, so that table will help out with those quadrantal questions. Let's keep it going here. How about reciprocal identities? Okay, when we use the word identities, we're pretty much talking about formulas that always work for any value of the variable, in this case, an angle, theta. And these are the ones we did talk about a little bit last time, the reciprocal identities. Cosecant is just the reciprocal of the sine, right? And vice versa. Sine is the reciprocal of the cosecant. So each one has a pair. Cosecant goes with sine, secant with cosine, and cotangent and tangent. Okay, so if you know that the sine is 4/5, you can find the cosecant very easily. Just flip it over, 5/4. Okay. If the cosine is -√3/2, secant is -2/√3. This one, got to rationalize. Oh, okay. So that would be, in the end, we'd have -2√3/3, right? Cotangent is 1/√3, tangent, flip it over, that's √3/1, or that's just equal to √3. I should circle my answers. And then tangent theta is 0. So if tangent is 0, cotangent is 1/0. Oof, can't do that. Undefined. All right, cool, moving right along. Those aren't too bad. How about signs of function values in the different quadrants? Okay, so it's helpful to know if the function is going to be positive or negative. So in quadrant 1, everything is positive, right? Because x and y are positive. But in quadrant 2, x is negative over here, right? It's the negative x-axis. Y is still positive though. So anything that is the sign, because sign goes with y as far as the definition goes, sign is positive, and therefore so is cosecant. Everything else would be negative, right? So cosine, secant, tangent, cotangent, all of those are negative. Okay. Similar reasoning in quadrant 3, tangent is positive, and then so is cotangent. Everything else would be negative. The reason for that is because both x and y are negative, and if it's negative divided by negative for tangent, that will be a positive. Okay. And then finally in quadrant 4, just the cosine is positive, and then therefore the secant as well. Everything else negative. Okay. Sometimes you see this written as A, S, T, C. All students take calculus, something like that, right? Where that's just a memory aid of where they are positive. All, A stands for all, S stands for sine, T for tangent, and C for cosine. And then everything else besides their reciprocals would be negative. Okay, so we can apply that to number 15, find the signs of the 6 trig functions. As long as we know the quadrant, we're good to go. So 145 degrees is in quadrant 2 because it's past 90 but not quite to 180. So in quadrant 2, sine and cosecant, positive. Anything else, negative. So I would put a plus for sine and cosecant, and then negative everywhere else. How about 255 degrees? 255 is past 180, but not past 270. So between 180 and 270, that's quadrant 3, where tangent and cotangent are positive. So tangent positive, cotangent positive, everything else negative. Okie dokie. Okay. Some detective work here. Identify the quadrants of an angle that satisfies the conditions. So what if both cosine and sine are negative? Where does that occur? Cosine, think of it as going with x, and sine as going with y. They're both negative over here, right? X negative, y negative. That happens only in quadrant 3, right? Any other quadrant, one of those two is going to be a positive value. Okay, how about number 18? When cotangent is negative, less than 0, and sine is positive, greater than 0. Okay, so where is sine positive and cotangent negative? Well, everything is positive in quadrant 1. All right, if we go back up here, right? So it's not there, right? Quadrant 2, sine is positive, right? So that satisfies that one. Quadrant 2. Is cotangent negative there? Yeah, because everything else is negative except for sine and cosecant. So this one, quadrant 2, certainly works, and no other quadrants would work, right? Because sine is negative in both quadrants 3 and 4, because y is less than 0. Right? Okay, so I hope that helps with those. How about this next type of problem? We're going to talk about ranges of the trig functions. Okay, so again, we're just really discussing lots of different properties of these trig functions. Okay, so it turns out for sine and cosine, if you recognize these notations from algebra, the range is between -1 and 1. Maybe this one is the most helpful, right? Just means that if you calculate the sine of an angle, it's always a number that's between -1 and 1, and same for cosine. Okay. That's just because x and y will never be bigger than r. R will be bigger than both x and y. So the definition is x over r and y over r. It's always going to be less than 1 or greater than -1. Okay. Tangent and cotangent don't have that property because it's a ratio of x and y there's no restrictions on those as far as which one's bigger. So the range is just any real number. Okay. And then for secant and cosecant, those are the reciprocals of sine and cosine. So there the range is opposite. It's not between -1 and 1. It's on the outside, either greater than 1 or less than -1. Okay. So to practice this, we've got some examples here. Is it possible or impossible? Can the cosine of an angle be -5? That's impossible. Let's just put I for impossible, so I don't have to write out the whole word. No, that looks like quadrant 1, doesn't it? Okay, how about we'll put impossible, IMP. How about sine equal 0.5, number 20? That's possible, right? Because it's between -1 and 1. Just do possible. Yeah. How about tangent could be anything, so that's going to be possible, right? How about cosecant 0.25? Nope, can't do it, right? Because cosecant's always going to be greater than 1 or less than -1. So that's impossible. Secant -8, for sure. We can do that. It's less than -1. Okay. Cotangent points, yeah, cotangent, you don't even have to think about it. It's possible. The POS stands for possible, not positive. Man, that's confusing. Let's just write those out. Okay, so hopefully, I'm really sloppy there. Impossible, impossible. Okay, so hopefully that helps with those. Again, you're just getting used to what kind of answers you could get. This will come into play kind of as we go through the semester with all these. So just setting some groundwork here. One more on this page. Oh, no, two more. Okay, got our work cut out for us here. How about find the exact value of tangent if sine is -1/4 and theta is in quadrant 3. Now we're starting to get into some that we're going to have to go back to those definitions. Right? I find that drawing these out might be helpful for in quadrant 3. That's down over here, right? If sine is -1/4, remember sine theta is y over r, right? So we could assign y as -1 and r as 4. Okay, so think about this as a triangle, -1 and 4, like that, right? Because r is the distance, that hypotenuse, and the y value is the vertical value. And then if I could just figure out what this x value is equal to, then I can translate that into a ratio for tangent. Okay, and let's just go with Pythagorean theorem, right? We know that x squared plus y squared equals r squared. So x squared is an unknown, y is -1, and r is 4. All right, so now we're going to do some algebra and just solve this equation. X squared, -1 squared is +1. Now I can just subtract 1 to the other side, so x squared is equal to 15. And so x is the square root of 15. It could be positive or negative, right? That's when I'm going to look at the picture. Or if I'm in quadrant 3, what do I know about x? So it's going to the left of the y-axis. That's a negative value. So this would have to be a negative root 15. Finally, now I can do my ratio for tangent. And let's just squeeze it in down here. Sorry for the sloppiness. Tangent is y over x. Right? So maybe I'll do let's just do this. Move that up a little bit. Use some fancy technology. Give myself some room. Okay. Tangent of y over x is going to be y was what? -1? x, we just found negative root 15. Okay, and then those negatives will cancel, so we just get 1 over root 15. Rationalize it, sorry, this one's kind of going crazy. Root 15 over 15, right? Again, doing my little orange rationalization, multiply both of those by square root of 15. Okay. Okay, that one involved a little work, right? Probably should have left myself more room on that one. Let's just finish this page off. We got one more, okay? Find the exact value of sine. We're in quadrant 4. Secant is 5. So if you're in quadrant 4, over here somewhere, if the secant is 5, that means the x is 5 and the r is 1, right? Think of that as 5 over 1. And remember, secant by definition is, that's not right. Secant, let's go a little more careful, is r over x. R is 5, x is 1. Good thing this can erase. Right. R is 5, x is 1. And that's a positive 1. R is going to be always positive, okay? R will never be negative. Okay, so this is the y that's missing. We need to find that y. All right, so 1 squared plus y squared equals 5 squared. All right, I can calculate that out. That's going to be 1 plus y squared equals 25. So y squared equals 24. All right. So y is square root of 24. Now notice y is negative because it's in quadrant 4, downward below the x-axis, negative root 24. Now you can simplify that. We haven't done that yet, right? Remember that from algebra? Reducing the square root of 24. It's 4 times 6. 24 is 4 times 6, which is 2 root 6. So this would be negative 2 root 6, right? Okay, and then finally we want sine, right? So sine is y over r. Y, what's y? Where's my y? We just found it. Negative 2 over root 6 over r. R is 5. Final answer. That looks simplified, reduced, and rationalized. All right. So hopefully those weren't too confusing. Let me know if you need any help. I'm here to help. Okay. I'm going to stop there. Been talking too long. Talk to you later. Bye.